Hi there and welcome to Julian's Tech Bites. In this podcast, we'll explore a new tech topic every month with two guests. So thanks for being here and let's learn together. Welcome to this new episode. Today we're going to talk about data science and machine learning especially. And for that today I have two people with me. I have Maike. Hi Maike.
Hi Julian.
Can you present yourself quickly?
Yeah, sure. So I'm Maike. I work as a machine learning engineer at ING, specifically in the department of omnichannel. We build the digital bank for the retail customer. And for the past almost 2 years, I've produced end-to-end machine learning projects. That means from model to really production, bring them to the customer. And that's what I worked on.
Thanks. All right. And next to that, next to her, we also have Vaidas. Hi, Vaidas.
Hello, everyone. My name is Vaidas. I'm a chapter lead of data science working at ING at the one-to-one analytics tribe. Chapter lead is a bit of a strange role. Well, essentially, it means that I'm doing two things. So for about half of my time, I work as a team lead of a data science team in building data science AI products, coaching team members, finding impactful initiatives to solve. And for the rest of my time, I work as a regular data scientist on programming, work on machine learning problems and similar. Mostly we are focused in customer interactions domain. However, we work on quite a broad range of machine learning problems. And we build really cool stuff for ING.
I will say that soon. All right, thank you. The topic today is very broad. I mean, machine learning, data science, AI, we heard all of those words already. We're going to try to understand them a little more and then maybe get people excited about it. My first question to you is, okay, I'm an engineer. I have 10 years experience. Why should machine learning be interesting to me? I mean, I do backend, for example. What's the point of machine learning for me? Can you maybe start, Vaidas?
Sure. Well, I think if you are an engineer of 10 years, you've been working on a back end or a front end or whatever, you have probably heard about data science. You have probably heard about machine learning. It is a really booming field in the industry. People are talking about it. There are more and more people working in this area. And what you see is that a lot of the companies, most of the technology companies who are at the frontier, you can think of Facebook, Google, Uber, ING as well, perhaps. They're focusing and they're more and more into data science and analytics. And as an engineer, I think it changes the engineer's job quite a bit as well, which means that you have to interact and sometimes work with AI products. You have to work more and more with analytics tooling, also analytics people, make different decisions, and potentially even use some of these concepts yourself. So this is coming.
All right. And Mike, maybe can you maybe elaborate? And as an additional question, like is there an example where you actually have brought direct value to me as a backend engineer? Like I know you've been working on some models at ING. I'm wondering how you've interacted with them and what effect it had on their work.
Yeah, so the first project that I joined right after I joined ING basically was a project that where I collaborated directly with a traditional backend engineer. So I had the machine learning data science background and he had the engineering background. And he was quite interested, just as you are right now, to learn a bit more about machine learning, what it can do for him as an engineer. So we teamed up, we were a couple up, and we brought a project together to production. And I think I agree with Vaidas where, machine learning will come more and more closer to the dev engineers as well. And I think you can only benefit from the background, a little bit of knowledge about it. Since you already know how to code, it's just an extra step for you to dive into the data science machine learning part. And I think there's a lot of value that you guys can capture if you're interested in the topic, right?
Okay, thanks. All right, yeah, that makes sense to me at least. I'm wondering. So, I the first example I have is, I mean, a lot of the things we're hearing about lately is data-driven decisions, right? You're using your data to drive your business and also to drive your decisions and maybe even your processes. I'm wondering to what extent it, um, let me say it that way. I'm using monitoring on my level. I'm using simple statistics, and it already brings me that far. What can machine learning help there? And is machine learning sometimes the only way to move forward in certain domains? Maybe you want to start, Maike?
Yeah. So I think that um, sometimes simple metrics and analytics techniques can already give you enough insight into your data. But I think if we talk about the face recognition on your phone, that kind of feature that you love so much every day, that's something that is, I think, very difficult to solve without machine learning. It's impossible to solve without machine learning. You can say it that way, I guess. Um, that's just one example. Thinking about voice recognition, it's also a really hyped feature that consumers really love at the moment, and that's also based on machine learning technology. So I think those more advanced use cases, they do need that machine learning component.
Okay. Want to add something? I see you moving around, Vaidas. Do you have any additional note?
Uh, well, indeed, I think there are a lot of areas where machine learning has really made big breakthroughs, and especially in area of developing completely new products, like Maike mentioned. I think next to this, an important area where machine learning is adding additional value is improving sort of more regular products by making them much better. So if you think about search, for example, search used to be pretty bad back in the day. Now, if you Google for something or use other search engines, you find stuff pretty soon, right? It works really, really well. So these kind of products, or you can also think of recommendations. You can do them with some statistics and quite a lot of business rules. But if you want to do this really well, if you want to add really a lot of value, you need to use machine learning, and you need to use really advanced and complex methods.
All right, thanks, Vaidas. I we just talked about machine learning quite a bit. We mentioned the word machine learning at least 10 times in the last 2 minutes. I'd like maybe to take a step back, and can we make the difference? Can you help us understand what the difference between machine learning and AI is, for example, and what data science is to that? I'd like to understand a little more. Are they the same thing? Vaidas, you want to start?
Sure. Well, to be honest, I think nowadays these three terms, so AI, machine learning, and data science, are used pretty much interchangeably. At some point, one of them is more hyped up. Some other times it gets a bit in the background. I think in principle they do mean a bit of a different things. In my understanding, AI is kind of a broad, fairly generic term. It has been defined quite a long time ago, I think in 50s and 60s or so, as something that computers do that humans would think it's intelligent, right? You can think of about anything here. You can think of all the solutions that machine learning brings. But you could also think of sort of fairly simple rules that you can code into computers that are uh, working on some problems that are really difficult to solve, and they seem like they're intelligent. So it's kind of a broader field. Machine learning, especially in a kind of research community, is really the area, is really the field of teaching computers or making computers learn by themselves. and this is also a technical term of a research area which has really picked up in the recent years. Data science, that's a difficult one. I think if you look at the LinkedIn job ads, you see so many different definitions of what the job is. That really differs per company, per industry even. Very often this relates to AI, especially to machine learning. What I do see also in industry quite a lot is that some people work on a product, so a bit more on analytics, trying to understand the data, make analysis, make reports, also base those reports or base strategic business decisions based on analytics and sometimes a bit of machine learning. That depends.
Okay. So if I try to put them together, like, just might be a little bit of a how do you call that? Of an exaggeration, but I feel like the AlphaGo engine, for example, which might be considered AI, is fed through machine learning, right? And needs data science to be fed. Like, are they subparts of a different? Yeah, go for it, Maike. Don't wave your hand, just go for it.
Yeah, maybe. I think you described it quite nicely. So how I see it is machine learning is just a technique to achieve artificial intelligence, right? So that is how it relates to me. If you ask me, do you work in artificial intelligence? I don't know. I wouldn't really, I don't know. To me, it's really just a buzzword. I feel much more comfortable to say, yeah, I do work in machine learning. Um, yeah, I feel AI is more like a bigger scoped umbrella term.
I find interesting, especially when preparing the episode, the uh, how do you call that? The connotations that time maybe has brought to us. Like, if you tell me AI, my first idea is some kind of Terminator, and data science is much more of a salesman dashboard or something. They have a different reputation somehow, that they're used in different contexts. I feel like maybe, or I wonder, and it's up to you to answer, but I wonder how much the media or the newspaper or the media in general has an impact on those terms. Like, are they using them interchangeably? Should you be a bit critical when you see those words being used, or are they used accurately most of the time?
I see them used really interchangeably based on the kind of purpose. I think media really leverages on that, especially because, as you say, a lot of people think of AI as this kind of a magical thing, like a Terminator. I see this a lot also in the funding raising community. So if you want to raise funds from venture capital, for example, you use the term AI because then people think, oh, it's probably something close to the Terminator, even though you're just applying to your business rules there. So indeed, it's used not in terms of how well defined it is, but in terms of, especially in the media, for the purpose of communicating that is. And sometimes it's a little bit frustrating, but at the same time, I think also as an industry or as a field, we're quite new. I think the term well, machine learning and AI has been defined quite a long time ago, but data science and people actually doing this have started about 10 years ago or so. So it's a new area, which means that a lot of
Okay.
terms get defined and redefined and reused in different contexts. So yeah.
I see a little less of the deep learning articles lately, so maybe it has gone a little out of fame. I don't know.
I see it
There are a lot of
particularly in the job vacancies. Um, there is not one job vacancy for a data scientist, just because the terminology is so interchangeable, and sometimes it's AI engineer, sometimes it's data scientist, sometimes
Yeah,
it's machine learning practitioner. So yeah,
that's a beautiful one. I like it.
yeah.
It's a practitioner. Yeah. Okay. Thanks.
Did you see this?
Um,
I'm curious now. Did you see a similar
Tell
trend
me.
for also software engineering? Do you know
Did I
like
see
how the
what?
field has for software engineering? Do you also see
Yeah.
like very different roles and that they evolve and sort of converge at some point, or?
Oh, that's a good question. There are definitely trends in the software engineering world. I mean, the machine learning is one of them. To be fair, I see. Well, and that's where I was a bit surprised by your answer, Maike, because I feel like in a lot more and more of the software engineer background, I see something like R pop up somehow. Like it's like what is that doing here? Um, but there are definitely trends. I mean, the cloud has been the one of the big ones from the few last years. If you think about Kubernetes, for example, that's the kind of thing that everybody is rushing into for good or bad reasons. It's up to you to know. But what used to be, a Java engineer very often now has a front-end component to it or an infrastructure component to it. I'm not surprised. Okay.
DevOps, I think, is also quite hot.
Which is good, but I do agree with the LinkedIn, the title things, and it's a bit of a headache sometimes if you want to frame your search. Like it's difficult to know exactly who's who and what's what, and
Yeah.
what is. Yeah, it's
I think
interesting.
one thing that I see in engineering community as well, I think that's where I first saw it, is that you have quite a few ads now for full stack engineers, and I start seeing them in data science world as well. I think some years ago when it all sort of started out, a lot of data scientists were just really really smart people who had just finished their PhD. They were very research focused, not very engineering focused. And right now you see there's really quite a big shift. More and more companies are going for full stack data scientists who can deliver end-to-end products, who know not only machine learning and research problems, but are also
Yeah,
able to code and connect different pieces. And that's increasingly more important.
yeah. That couples back to the first question I had. As it is becoming interconnected. It's how do you bring that knowledge to production and make use of it is a big yeah. Thanks a lot. If we think about the last few years, I wonder because you did mention already, Vaidas, that the last few years a lot of the companies are be focusing a lot more on data. Have things changed a lot? Like what brought that shift? Is there a specific reason why we started thinking, oh my God, I can make use of that data? Do you want to start, Maker?
Yeah, sure. I think what what is sort of the most common explanation that I have been reading about is that now we have the possibility to collect, store, manage huge amounts of data, right? Big data has become also a really big buzzword in the IT sector. And then also we have the GPUs to train machine learning models, right? Some of these models are computationally quite expensive, and that has become really cheap. I also think that with the rise of cloud providers, it has become even more easy for anyone to access these resources, and that's a really big opportunity.
Okay, makes a lot of sense. So you think that the the state of the technique and like the hardware has made a big has made it possible
On one
to a large scale.
hand, yes, and on the
Uh-huh.
other hand, the availability of the data and the fact that we can store it, manage it, collect it at scale.
Okay. It sounds familiar to me. Like 10 years ago, when I graduated from school, I remember I still have those books. I kept them. It's my computer vision book was about yeah, feature or was about computer vision, and there was machine learning in there. But for example, one of the examples was the neural networks, and I still have this note from the teacher saying way too expensive. Prefer using feature extraction first, and feature recognition rather than neural networks. And I feel like the world has totally changed now. Like 10 years later, um, neural networks, you hear about them everywhere, right? I mean,
Yeah, and I
do
think
you
also
do you,
think that the knowledge online is so
yeah,
rich. Like, if you want to learn about machine learning, oh my god, the amount of resources that you have online to teach yourself that stuff is, it's probably worth more than any degree, you know? It's just amazing. It's just open to anyone.
Isn't it?
I,
Yeah, go for it, Vaidas.
I think also a really big thing next to the ones Mike mentioned is also the emergence of open source. I think open source has really made it possible for a lot of players to pick up this technology themselves and apply it in a lot of different areas and fields. Back in the day, this was really kind of a research thing, more of an academic thing, and perhaps one or two companies had the resources and the ability to do this, but with open source, this has really changed. And combined with the resources and the technology and so on, it has really made a big impact.
I was just looking it up because I followed a course last year from Andrew Ng. I don't know how his name is pronounced, and his machine learning course is like top 5 ever on Coursera. So I mean,
Yeah.
it is a hot topic that people are interested in, clearly. So okay, thanks. Let's take a step back. Maybe one of my questions is, we talked about the interaction between machine learning or data science and software engineering. What's different? How is it different if I'm a machine learning engineer, or if I'm a software engineer, like a more generic software engineer, backend engineer, front end engineer? How is that different? How does it look like?
Yeah. So I think in regular software engineering, you have your code, right? And you have to take care of that. Okay, you have a bit more, but mainly you have code. In machine learning, you have the data, you have the model, and then, of course, the code that lives around it. So you have two additional components that need monitoring and that need maintenance. So you add more complexity to the system, and um, the the model component is also much more probabilistic in nature, right? Because if you as a software engineer, you write your code in a more deterministic way, where you know that it can either go route A, route B, or route C, and that's it. That's how my system will behave. However, the model behavior depends strongly on the input data, right? And that makes it, to me, quite different from each other. And I remember also that that was something that software engineers that I collaborated with, they were really bothered by that. That they
That
didn't
sounds
have
very
the
frightening to me.
yeah, that they didn't have
It's
the
not black or
control.
white anymore. It's
Yeah,
gray everywhere. Oh my
yeah, it
god.
is. It is really. So that's definitely the main difference to me.
Okay. How do you cope with that? What's the way to work with it?
Well, the way how we overcame it, and also this, I wouldn't call it frightening, but this also dragged into the business, right? Because your product owner and the people that you collaborate with from the business side, they're also used to regular software. So they also want to know how exactly is the system going to behave? What can I expect? So I think if you put proper monitoring in place and you try to give your colleagues the feeling that they have complete insight into the model and they know exactly what is happening, and they can pull the plug at any point, and they can grab their data scientist to fix it, but they are aware when they have to do it, and you give them the ownership. I think that really helped, at least from my experience. um, but yeah, I'm also curious what Vaidas maybe has to add.
I definitely recognize the points you mentioned. I think if I would need to add to that, one thing that I found really useful especially bringing it to the less technical business users, is that explaining model or making the outcomes or how the model works a bit understandable by a human also adds a lot of value. If they're somewhat more comfortable in using it, if they understand it, at least on a high level of what's going on inside, that makes it a really big difference.
Yeah, I do understand what you're saying, Vaidas. I think if I was a software engineer myself, I probably would like to understand what's sitting next to me and going with me on production. Would you how do you make that understandable? Like, do you have a technique, or how do you explain me as a software engineer that this black box that is coming, how do you make it clear for others?
Well, there are quite a lot of different ways to do this. It's also a big research field, how to make models explainable. There are a couple of different ways to do this. So, a most usual one, I think, is to give a bit of an intuition of how the model itself functions. So, if you have, I don't know if you're familiar with, for example, decision tree, you have to make a certain decision, and you kind of go step by step. In decision tree steps, you say, is someone older than 20 or someone less than 20? They say, are they male, are they female, and that sort of thing. So give them a bit of an intuition. Another way is to connect it with the data aspect and look at it from the perspective of what is the data that goes into the model and what does the model think and how does it make decisions. So what helps here is to, for example, describe what are the most important variables that go into the model and which of those model thinks has the highest priority or importance. I think that's the second way. And a third way is you can look into the outcomes of the model. So once you have the model trained, you have the input data, you know what are the variables there, you can see what the outcome of that model is. So if you're doing a face recognition, for example, you can know how many faces you recognized, or if you're trying to recognize cats versus dogs, you have some metrics to explain how many cats you recognize correctly, how many dogs you recognize correctly, and so on. So you have insight into the actual performance of the model through the metrics associated with it.
Okay.
Does that make sense?
That makes a lot of sense. Yeah, I mean those are things that I'm expecting most engineers to be used to in one way or another. So it definitely makes sense. All right.
So something else am I missing, Maike?
Yeah, I'm just thinking about the most recent project that I'm working on at the moment. We have weekly project deep dives together with the business, but it could also be that developers would participate. That doesn't matter. Just non-data scientists, and we really take them into the details of the method, still at a high level where they understand it and they really enjoy that, because then it's not like we're operating on our own little island and at the end of the project we dump a black box machine learning model on top of them, but it's really it's really a collaboration, and they learn so much about machine learning through the entire process, and they get so used to the model, and I think that also really helps.
All right. Yeah, sure. I mean,
you also have POs and CGs that are really interested in data science. That helps, huh?
That's what I was just about to say, that actually, if I think about my team, the data aspect of things is really interesting to the business, and that's an easy way to bring data science into the mix of software. It's a good angle to attack, and to get it in. Okay, you mentioned the important word model a few times, Maike. Can you clarify what that is?
Yeah, I have to think about that one for a second, because I don't have a textbook definition on top of my head. But I think a model is essentially, wow, a function that you model around data, right? So you're trying to fit a function around data so that you can make a prediction for a new data point.
Okay.
I don't know if that is a nice explanation. Vaidas, what do you think?
Yeah, it's a good one. I was also a bit taken aback by the
Vaidas
question,
trying
as
to cheat on
simple as it
Wikipedia.
sounds. No, I'd just say something that a data scientist makes, which brings business value through the use of data and the probabilistic outcomes that Maike described previously.
So would that be your deliverable in a way?
Yeah, yeah, I suppose. I think it's kind of a core thing that you work on as a data scientist. However, of course, there are a lot of aspects around it. How do you integrate your model into the current existing technology and framework? How you do the monitoring, all the rest of the stuff. But the model is indeed the kind of the core of it, of what we focus on.
Okay. Okay. And how do you build that model then? Are there steps that you always follow, or is it a fuzzy process? Is there methods? Do you have a framework? Any of you, Maike, maybe want to start?
Yeah, there is definitely. I think it's quite a fixed process. Um, in a way that you always start with a business problem, right? You don't do machine learning just to do machine learning. I think that is the worst thing that you could do. We're gonna do machine learning now because it's hot and because it's cool. That's really not what it's about. But it's about your team or your product owner having a specific problem at hand, um, where where you guys maybe already use a rule-based approach, and he wants to take the next step, for example. Um, but I do think it's important that that business problem is defined very clearly, and maybe also in terms of a hypothesis. So you want to improve sales by X%, and that's what you want a model for example. Um, yeah, I think that would be the first step. Define with the business what is the problem and what is the goal here, and why do you
Okay.
need a data scientist for that?
So essentially requirements.
Exactly, yeah, the requirements.
All right. Do you want to bring us further, Vaidas?
Yeah, sure. I agree with Mike that indeed that this is where it always starts. So talking together with the business, trying to understand what is the problem that you're trying to solve. I think from quite a bit of experience in doing that, I can say that usually the first ideas that you get and the first input that you get around what the problem is, especially how you define success, is very different than what you have in the end. So you start with something, but it's also a very iterative process. You redefine it continuously many times until you get into something really, really tangible and something that can bring value. So managing your expectations a bit. In a business, this process is usually much more tricky if you compare it with, for example, problems in data science that you can solve online. So if you go to like Kaggle, or if you look into some openly published data sets, those are usually very well defined. The data sets are clean. But in reality, that process is usually much more challenging.
Okay. So
I'm
here
actually
you
curious. Sorry, I'm actually
no, go for it.
curious, Vidas, how many product owner, business people come to you with their business problems, and how many times sort of do you reject them and say, "Hey, this is not really a data science problem," or yeah, I'm interested like how that goes for you.
Yeah, that's a good question. I think a lot of people, or at least some people, they want to reach out to a data scientist thinking like, hey, there's this hot field of AI. Surely we can do something with AI to make it better. And
How
frankly, I
can
think
you
that
help me? It's like, yeah, you
indeed,
tell me. How can I help you?
and that can be a right intuition. sometimes people have a more clear idea of how AI can help them. Sometimes it's achievable, perhaps at times it is not. But that's where we usually, well, frankly, it's difficult to say right at hand if something can be solved by data science and AI or not. So usually what we do is we also start this sort of iterative process in asking them questions, trying to understand what their challenges are, what kind of business problems they have, and also bring them a bit into the data science, into the analytics world. And this usually starts with just explaining what simple models do, perhaps showing some use cases that we worked on in the past that relate to their domain, also a bit in data-driven decision making. How do you use metrics to make your decisions? How do you evaluate if you're successful? And then after having this dialogue, this conversation, it's usually very clear to both parties if data science or AI or machine learning, whatever you want to call it, is the right approach at this stage.
Okay.
I hope that makes sense.
Yeah, it does. Makes a lot of sense. You mentioned data, usage of data. I'm wondering, my first question is, okay, but how did you acquire the data, and how did you make sure that the data was in a format that you can use?
You want to
Yeah.
take that on, Mike?
Three questions.
Yeah, so I think it is definitely a prerequisite to start a machine learning project. You need the data, right? Otherwise, there's no way that you can build a model. So there is the question of, do you have the data available? Have you already started collecting the data? Where is the data located? Can I access it right? Can I access it right away? Can I start experimenting with it? Then
is it GDPR compliant?
Yeah, exactly. Also, really big questions. And most of the time, the data comes raw. That means it doesn't have any labels. So let's say the business delivers a bunch of pictures to me and says, based on all of these pictures, I want you to identify cats and dogs. However, what my machine learning model needs to know, which pictures display dogs and which pictures display cats. So if the data is not labeled, and most of the time it's not, I wouldn't say it's a problem, but a lot of machine learning algorithms are based on what we call supervised learning. So we need labeled data. That's something you have to consider. And yeah, I think that is most of the most important stuff to get going. Let's say from the second stage, from the data acquisition stage.
And would you be, is it easy to, because I do know you mentioned Kaggle already, Vaidas. I think we'll talk about it a bit again later, but you meant, so there is data available on the market today already. I mean, if I think about cat and dogs, for example, I know there are data sets that are available that allow me to train my model. Are those data sets from outside my business easy to use, or is it better to have data from inside? Do I spend more time actually fitting my data to the data set from outside, or should I spend my time labeling instead? Are those decisions easy to make, or is it clear cut? Vaidas, maybe?
Sure. Yeah, it's a tricky one.
Okay.
Well, there are a couple of aspects to this. I think one is that a lot of the times the data from outside needs to at least to an extent resemble what you're trying to actually solve. So the cases where this is most often the case are when you're working with text data or images. I think those fields are really worked on a lot by a research community, and there are quite a lot of really interesting data sets and also models built on them. For example, there are some models in text or images data that are built by Google, which takes like months to train, or even impossible to train on a computer, which you can use. There's a very interesting area in machine learning called transfer learning, which is trying to solve exactly this problem. It's trying to understand how can you use data sets or models built in one area or one field uh, into something into a new domain. However, it's also quite a new field. A lot of researchers in deep learning especially are focused on this. There are some successes in, again, text and images mostly, but in practice, that's quite tricky. So if you're using tabular data, for example, I think you need to start with something with the data that you have internally, and very often you will need to find labels that are internal as well.
Okay. Good answer. It depends, but probably not.
I must say,
no,
though,
that makes sense.
quite a lot of business stakeholders actually come through the angle of, hey, we have some interesting data. Can you guys do something with it? Which I think is a good opening, but usually that still takes quite a bit of refining and a few steps to find where is the real value there.
What was going on my mind as well is, and I don't know to what extent that is true, but text and images, you could argue, and it's the same for satellite images, I believe, are less specific than, for example, financial models, which are maybe much closer from your core value as a business. You might not want to collaborate so much around those areas, right? So I would expect that there's less data sets about, budget planning, for example, available than images. But I might be wrong. What do you know about that, Maike?
Yeah, I've used a lot of pre-trained model from text, because language is so generic that most of the time there's only let's say a final layer missing, where, for example, when we talk about the financial industry and we talk about customer facing products, we just need the domain language, right? So we need in these public data sets or in these publicly available trained models, they don't have that domain language in them because it's just too specific. But you can find ways around it. So I think for me, it has always worked out quite well. And I think there's a huge opportunity in that. But then again, I guess it depends on the business case. You can have really specific problems where you can not use any pre-trained models at all and you just start from scratch. It really depends. But language and images, voice recognition, I think that's a field where you can utilize what's already out there.
Okay. All right. Coming back a little bit. So you talked about training your model, specifying your requirements, or if I take that in the proper order, I guess, first specifying your requirements, knowing where you want to go, and then making sure that the data is available, and then training your model. Are there any other steps that you want to mention? I'm guessing we can go very deep here, but are we missing crucial steps to be able to build our model and share it with others, or are we complete? Vaidas, maybe?
I think after an obvious step of acquiring the data, there's the not so interesting but very essential part of data cleaning and making it useful. So as an engineer, you're probably quite familiar with this, right? You have a lot of different data coming from different streams in different formats at different time frequencies. It's not very clear how to match it. Also in the organization, it's sometimes difficult to find people who know how to match it. and so on. So there's quite a bit of cleaning and then sort of matching and integration of data going on in that stage. Also, you need to make sure that it's in the right sort of format and that it's ready to use by the model. So you need to transform it to different format or different representations. Do some, we call it feature engineering. It's quite an essential step, and it's also usually quite a time-consuming step that normally, if you work with data sets available online, you don't think about it very much.
Okay. Any last
Yeah,
words, Maike?
I think the success factor with the open source data sets, you get it much quicker just because they're so nicely prepared for you, and they're also sometimes quite tailored to give you good results. Where when you do really work in the field, you have to have some endurance because that will take you some time until you see some promising results that you might want to take to production.
All right. Okay, I'm wondering. I have two burning questions, and I'm wondering in which order I want to bring them. And I think I'll be talking about going to production first because we mentioned the whole building, the building of the model. So your model's ready to go. Your model's trained. You're happy with the results. How do you deploy to production? What's the typical workflow?
I don't know what is the typical workflow, but
We can maybe.
I mean,
we
work for we work for a bank, so we have a Java or JVM backend systems, and data scientists work a lot in Python. So we develop a lot of Python models. So yeah, ideally what you would need is a Python runtime environment to expose these models, for example, via an HTTPS endpoint in an application. You would like to do that. Now, that might be a little bit challenging depending on what kind of company you work for. I think the bigger the company and the more set in stone their backend systems are, the more challenging that could be. But what I did in the past is I deployed a model in a Docker container and I deployed a model in a Java API.
Okay.
I've done that as well. Yeah. So
how does it look like in an API? Do you have like a file that you use as a, like, how does the model look like in a Java API then?
It was just pure Java code basically. So there's
All
also machine learning libraries for Java. Even deep learning frameworks. So yeah, very interesting. It has, now that I explored that world, it is so much more limited than what's available in Python, just because the community is really focused on Python, and I think maybe even R. I'm not sure. I don't work a lot in R. But yeah, it's just Java code.
Hey, thanks. Yeah, that makes sense. I'm guessing the easier option would be to use Python, but other options, depending on the requirements of the team you're working with, would be to use the language that they're already using, though it might be less easy for you, or containerize your application or your model, and then use that as a black box. Yeah, that gives a few options. What about front end though? What if I'm in a team that doesn't have any backend and is running full front end applications? What's happening then?
TensorFlow.js. Yeah, it is a thing apparently.
Do you have experience with it, Maike?
No, not at all, to be honest. No JavaScript experience whatsoever. So I left that completely untouched.
Oh, me neither.
Okay, thanks. And to be honest, I wonder what the penalty would be as well for the user. Anyways, we're reaching the one of the favorite parts of the episode for me is you've been pumping me up for an hour. You've been talking to me about machine learning. So I'm wondering now, okay, how do I get started tonight? What tools should I be using? What libraries do you recommend? But also, I'm guessing something that's true for machine learning is how do I find a specific problem that I can solve? How do I find data that I can use? What's the easiest way to go about that? Do you want to start, Maike?
Oh. I think if you just want to have a little bit of fun, then I think you should definitely check out one of those websites where you can find open source data sets, right? Like Vaidas already mentioned Kaggle. I think that's a really great point to start. You already have a problem to solve. You have the data available there. You can just download it, and you can get going quite easily. And then otherwise, I would probably recommend to look into notebooks. That's something that data scientists use to experiment with different models, explore data. You can imagine it. It's like a combination of text, code, visuals. It runs in the browser, so it's a runtime environment at the same time. And there are a lot of tutorials out there that use Jupyter notebooks, and it makes it super easy to get started. So I think equipped with that, you are already halfway ready to go.
Okay. And you, Vaidas, would you recommend the same thing?
Oh, I think it sounds like a good start. Depends a bit on what your background is, and perhaps some of the languages you're more familiar with, right? So if you're familiar with R already, you can start with R. I know there are some packages in Scala already, so if you're big on Scala, that might be an option. I would also pick the same route of Python, Jupyter Notebook, because that's what I'm familiar with. It works really well, but there are a lot of different frameworks written in different languages. You can find a flexible tool, especially for starting out. You can start in a language that you prefer.
Okay. Correct me if I'm wrong. Kaggle is also some kind of competition, right? You get to perform your model against others, right?
Yeah,
Yeah,
sometimes.
indeed. So if you're doing really, really well, you can even win some prize money.
Yeah, the Netflix recommendation system originated on Kaggle, right?
Not sure.
I think it was
Then
initially a
they had a big
competition.
prize.
It had a really big prize, yeah.
So did they hire the winner?
It was $100,000, I think, competition to find a better recommendation system that Netflix is using, and it was won by a team of data scientists. However, an interesting thing, in the end, they did not implement the winning algorithm because it was too complex and difficult to implement.
Really?
Yeah, yeah. It was beating all the other models, but still it was too cumbersome to use in production.
So what do you mean that they wrote a specification of the model in the end, the winners?
Oh no, so the team that won obviously built the model, and they were able to run it against the benchmarks to determine that they're the team that won. But Netflix themselves did not implement it in their system.
Ha, I really like that actually. I like it because it brings us back to the fact that we're also having to, be conformed to certain specification. It's not only about having the best model, but it's also being practical to use, and so that's actually a nice learning experience. Okay, so we're reaching the end of the episode, and that's one thing I always like to do is, okay, famous last words to both of you. Is there something we haven't touched that you would really like to mention? And I'll start with you, Vaidas. What would you like to say that we didn't talk about today about machine learning and data science? in general, or something specific as well, by the way?
Well, I think one of the very interesting areas in this whole machine learning world that a lot of people are focusing on right now is also fairness of models. You can think of fairness as something that is sort of encoded in the data. Let me think of an example. So imagine that you're making a model to predict whom you're going to give out a loan and whom you're going to reject for a loan. And obviously, you want to be fair to different groups of people, right? So you don't want to include attributes such as gender in your model. You don't want to be unfair to one of the genders. However, the problem is much more tricky than that. And the issue here is that you might be including some of these aspects implicitly. So for example, if you're including a postcode in your model, that postcode could mean that more people of a certain background live in that postcode than the other one. See? And all of these different issues mean that sometimes models can discriminate even without sort of designing them to some particular groups and be fair or unfair towards certain individuals. And this is a really, really tricky problem because also from the research point of view, it is impossible to be fair at the same time to different groups and also to different individuals. So this is a interesting problem that the community is tackling right now.
That's actually a very interesting point that you're making. And I wonder, like, I worked with someone for accessibility, for example, like how we embedding that today, ethics and fairness, are we embedding that into our models, or is that something totally new? Is there a market for that? Can you tell us more about this?
Well, we have increasingly more people working in this area. However, it's a really new area. There's a lot more interested in it from also the regulators of the whole industry that want to bring fairness practices, and also some big industry players like Google and Microsoft. They're also putting a lot of effort in this area.
That makes me think a lot about this story from last year with I think the Apple credit cards that they have in the US, where some other people, but including Steve Wozniak, had a problem where he's living with his wife for 20
Yeah.
years. They have the same bank accounts. They have the same, yeah, everything is, they live together, they're married, but somehow she gets 10% of the credit rating that he has. And when he called Apple support, they said, well, sorry, it's the algorithm. We can't do anything about that. I find that a little scary.
Yeah, indeed. Well, I think what some people don't realize fully is that the reason it is the case and the reason it is disturbing, because this is the reality that we're living in, right? The current situation is exactly this. That's why the model is learning from this data and is learning those outcomes. And I hope that this initiative of fairness in machine learning is also going to bring a change into our society. So once we realize how unfair or fair some of the models or decisions that we make are, we can also try to change them and understand how to influence them in a better way. I think this is a very, very exciting challenge and also opportunity for our society as well.
So you're talking about basically AI removing all biases.
Indeed, indeed.
Okay. And you, Mike, do you think Terminator will bring us fairness? What do you
Ooh,
want to add before finishing?
I really don't know, guys. No, I think you guys actually really beautifully described that, especially the last part about actually these models reflect uh, society how it is right now. So I think that is the most interesting part about it.
Right. And what better to finish an episode about machine learning than fairness and ethics then? All right. Well, that's going to be a wrap. Thank you very much. We talked quite a bit about, yeah, we talked about a lot of things. We talked about the difference between the different words that are being used every day, machine learning, AI. We talked about how to go to production with it, the difference with normal software engineering. Finished on ethics. I really appreciated this discussion. Thank you very much, Vaidas. Thank you very much, Maike. It was a pleasure to have you today, and I hope to see you again next time.
Yes. Thanks for
Yeah, it
having
was fun.
us.
Thanks.
All right. Then thanks for listening, and see you next time for another episode of Julian's Tech Bites. Bye.